Okay, welcome back. So we're going to, right now what we want to do is complete the descriptions of what we've already started on the last page of the female reproductive system. So what we're going to end up doing is just transferring everything we've said to the next page. Okay, so page over, here we go. You can also, maybe it'd be a good idea to leave it open like so. And so that you can refer back and forth. I'm going to leave mine, as a matter of fact, I think I'm going to tear mine off. That's better. I can do that. It's terrifying. Very good. So, A, obviously. Leave me alone. So most of the stuff you guys already know. Granted, maybe that's one of the advantages of starting off with talking about reproduction, is that you guys already know it all anyway. It's all good. The word that we're going to be using interchangeably for eggs is ova. Ova is plural. Ovum is singular. Okay, so this is plural. Produces eggs and follicles. And the follicles are going to produce two things. They're going to produce estrogen, estrogen with a T, estrogen, and progesterone. Okay, and we will, when we talk about the different secretions, we'll learn more about that as well. B, where are we? B, uterus, aka womb, and it's basically a compartment for fetal development. See, I know you know this. For fetal development. Leave me alone. C, we already said that comes under, actually I heard a third term recently, but we're going to use either oviduct or fallopian tube. This actually, true, it transfers the egg to the uterus, but it is also, this is the important thing. I'm going to put a little star here just to designate this is important. This is actually the site of fertilization. Okay? Fertilization does not occur in the uterus. If it did, it'd be too late. What happens, if you just go over here, if an egg is released and it's starting, the fibroids start to wave it down through this fluid-filled oviduct, what happens is that the sperm actually has to swim upstream, fertilize it here, because what has to happen is that fertilized egg has to go through a certain number of divisions before it can implant in the endometrial wall. Okay? Now, here's the rub, if you pardon the expression. Here's the rub. If the egg actually got down into the uterus before it was fertilized, it does not have enough time to go through those divisions to make it ready for implantation. Okay? There is a problem, though. There's another problem associated with this. And that is that sometimes the egg will be fertilized, but it won't actually make it down into the uterus before it implants. It is possible that it will implant in the oviduct. This is a big problem. This is called an ectopic pregnancy. And normally this is life-threatening for both. Big problem. Okay? And so I'm just going to put a little reminder here to that effect. Oh, you can't see that, sorry. You guys are going to have to be on me about moving stuff around. Except Coker. Go in. Yeah, ECTOPIC. So an ectopic pregnancy. And this is when a fertilized egg implants here. Okay. D is the endometrium. This is the monthly renewed buildup of tissues, and I'm going to cheat here. For blood vessels, I'm going to put V period for implantation. If there was a pregnancy, okay, the endometrial wall will become the placenta, and the placenta will be lost at delivery. Okay. I think that there's actually a shelf life involved with the endometrium, because if there is no pregnancy occurring, it's highly vascularized. Vascularization means that it's just an incredible amount of blood vessels that end in a very large amount of capillaries. Okay? And it needs to be renewed, just because it will degrade over time anyway. How many of you guys watched the Khan Academy videos? Okay. No, seriously, they go into a bit more detail than I do, or is required for this course, because they're also aimed at like university level as well. Highly recommend looking at that. I think of, like, the other day when we looked at the male reproductive system, it was mind blowing what's involved. When we look at this, the female reproductive system, if your mind wasn't blown then, your mind will be blown now. It's absolutely best possible design ever. That's all I can really comment to that. If you were to watch the video on, I think it was like the first video, the moderator was talking about how many eggs that are actually used throughout a female's reproductive years and how many are lost. It turns out that every month, 1 egg is produced. Sometimes 2 or 3, but that's usually as a result of the mother taking fertility drugs. But up to 25 eggs never develop, but they're lost. So when you get to menopause, basically the reason why you female hits menopause is that she essentially run out of eggs or primary oocytes. It's run out, so she can't get pregnant. Okay. Yeah. Good question. Don't think I answered it. I don't think I answered it well, except that it has to be redone in order for there to be a successful nutritive site available. Okay. Cervical canal. So passage point for sperm entering and endometrium exiting, obviously. So this, of course, is referred to as menses. F. Where am I? There we go. Menses. Yeah. Menses is the actual technical term for menstruation or menstrual cycle or things like that. That's the actual technical term. Okay? So vagina, obviously, for intercourse. Another passage point. And for childbirth. Sometimes they will talk about, they'll use the term birth canal when they're talking about the vagina, childbirth. And so I'm going to just put AKA, birth canal. G is the hymen. Oh, whoa. Are we too far ahead? Huh? Okay. Yeah. Oh, thank you, dear. G is the hymen. Now, the hymen is a thin tissue that can, depending on the individual, can take different shapes. It's thought to be a partial barrier against bacteria. Okay? So a girl is born, and probably she will not have intercourse until, say, late teens, early 20s. Okay, just to give some kind of time frame. That time period in between, though, just by the nature, the physiological nature of the female body, is that females have a higher potential for vaginal infection than males do for urinary tract infections. Okay? Are we okay with that thought? I know. I'm so glad I'm not female. Okay, bring it down, bring it down. Okay? So, depending, like the way that they have shown the hymen here, it looks like it's just another partial flap, but that's not actually true. If you were to take, this is a cross-sectional view, if you were to take an end-on view, you could have hymen could be like what the picture indicates. It could be like that. Yes. It's, wow, that's great. It's like a drain cover, really, and functionally too, because it has to have perforations in it so that during menses, the endometrium and blood can flow through. But it actually acts as well as a partial barrier to bacteria. Okay, so on the first occurrence, of intercourse, that hymen is broken. Now this has very significant cultural implications on it. There are cultures, there are cultures that when the bride and the groom consummate their relationship sexually, I've seen videos of once the wedding ceremony is done, they go into like a tent, have sex, and if the sheets do not have blood on it, what that is implied is that the woman was not a virgin. I know it's not. Yeah, I totally agree.
Come on, 2019. Okay. It's just went sideways. I love this class.
Okay, so the next question. Okay, so hymen. Shut up. The hymen, that's what's broken when we...
Yes.
And then, but like tampons?
They don't penetrate that far. Okay? Okay, the hymen is up higher. I'm still waiting on the question. I'm not sure the question is.
Oh, I'm sorry, I'm just creative. I was just learning.
All right, already. Gee whiz. Okay, what is your question?
Back again. My question is,
Yes.
Go far enough. Ask him.
6 with the Asian.
I would say that because we are different individuals, there is variation among individuals. Yes. And my point in drawing this out was that there is considerable variation. Now, I'm not sure. I'm not sure. I'm not sure, but I was anticipating that one of your questions would be, or maybe I even kind of partially heard it, is it necessarily so that the hymen will be broken on first intercourse? Okay? The answer is not necessarily, because if it is of this version, the opening is larger, potentially it might not. And so, like, seriously, when you look at some of the Eastern or Mid-Eastern religions, at Muslims and
How you doing, Mr. Hayden?
I'm undecided.
How you doing?
22 minutes.
potentially, because it's too bad. Yeah. Yeah, what she said.
Basically, I didn't hear that. It's the hymen is not always broken during first intercourse because different shapes, different people, whatever. Okay.
Yeah. And here's guys, it's actually quite serious. It's serious enough that a woman's life could be in jeopardy. No, I'm serious. Because for a woman not to be a virgin at the time of her marriage, that means that she was having sex before marriage. In some of these faiths, that's punishable by death.
What about the guy though? Like they can't tell us the guy just like.
That's what I mean. She says it's horrible. Like I think Alea said, that this is horribly unfair. I agree with you. I agree. Like, seriously, think about this. Biblically, when you're talking about the story of the woman caught in adultery, what happened to the guy? He's not even mentioned. No. This is Bible. This is Bible in the guise.
I know, Rick.
So
Oh, like when I was but only for 1 second. So rest in peace. Yeah.
Okay, so those intervening years, that's what it's thought to be. Okay? And so there's two other structures, H and I. H is called the labium minor. And the labium major. And those also are thought to be part of the same system. So I'm just going to put ditto, ditto. Okay? So between the three layers, it's thought to do two things really as a physical barrier. But remember when we talked about the male reproductive system, we said that it was necessary for the sperm to get past the acidic nature of the vagina in order to successfully survive. Well, here's the way you could think about this. If you have the hymen, the labium minor and the labium major, those act kind of like as compartmentalizing the environment, such that if bacteria did get in through into the first compartment, it is still compartmentalized and enough, hopefully, that the acidic nature of the environment would kill it quick, a more effective kill, right? Same thing is if it got passed into the second compartment, again, a more significant kill. Believe it or not, there is another compartment between the hymen and the cervix, which again gives another compartment where there could be kill, bacterial kill. So when you're talking about, these are like multiple protective zones, really. This is what I mean. It's like, this is brilliant. Like, seriously. I'm talking about making allowance for every possible contingency. You'd almost think somebody designed this. Yeah, you would. J. J is, can't see that, it's in the way. This is just the cervical opening. And I'm just going to say C, E, because it's cervical canal, cervical opening, same difference. Okay, page over. Page over. Two last ones, which is cervix. Oh, am I on the page? No. Cervix. And this is the muscular containment. Yeah, containment of the developing fetus. And last but not least, the uterine wall. And we already actually talked about this. This is allows for muscular contraction. Cervix is muscular containment. The uterine wall is muscular contraction. And so this is obviously during childbirth. So the muscular nature of the cervix is important to contain the child so that he isn't preemptively lost before reaching full development. Okay? But at the same time, when the child does reach full development and it's time to be delivered, there has to be some forceful expulsion, if you would. And that is also partially acquired through the uterine walls. Abdominal muscles play a role as well. Okay. Oh, before I go on, I forgot to mention something to the gentleman in the crowd. When we were looking at the male reproductive system, we talked about the erectile tissue, spongy cartilage. Okay? Now, have you ever wondered why on God's green earth we have little blue pills called Viagra, and what's the other one? Cialis is one of those ones now too. Have you ever wondered what the heck is going on with that? Here's the reality. In these days, because of our poor eating habits and our poor exercise habits, our cardiovascular system is somewhat lacking. In other words, our arteries and veins tend to get closed off with plaque buildup. Now, it turns out that the reason why there is a higher incidence in erectile dysfunction nowadays than there was in the past is because of those two things. So, gentlemen, if you're planning on having sex beyond 40, take care of yourself. Make sure that you have an adequate eating plan and an adequate exercise plan, or you're going to be subject to little blue pills. Just saying. Okay? So that's another good reason. Another good reason to maintain a healthy lifestyle. Just saying. Yes? No, it's true. It's actually true. Because the blood vessel that feeds the erectile tissue, that gets closed off. And that's why the Cialis and Viagra are vasodilators, which means that they cause, and these are specific vasodilators, to that particular artery. So, ladies, when you get married, insist that your husband eats well and that he is on an exercise program, because us guys are not very good at these things. Just saying. Okay, this is where things start going really sideways. Okay, this is a diagram that is trying to represent the a monthly cycle of what's going on in an ovary. Okay, so I'm going to begin by drawing a timeline around the outside of this, and A right here is basically day 1. I'm actually just going to put, I'm not going to put the word day. It's going to take up
Can you read the paper, Mr. Hayden? Kind of right on the edge there.
It's like 1, 14, 17, and 28.
Oh, it's 7.
I do not think about this. I don't know.
Okay, so some of these numbers,
These are the days, aren't they?
these are the days. So, hello. So, obviously, this is been constructed to go in a clockwise direction. All right, and
Wait, that's 17?
no, where?
That's 14.
This 14. Sorry, this is 15 right here. It's 15 right here. Okay. So, A, this is called the primary oocyte. Remember when we talked about spermatogenesis? The first what do you call it? The raw material was called it was called spermatogonium. Okay. Now, when a girl is born, she has all of the eggs that she'll ever have in her ovaries the day she's born. Okay, all of them are there. But what has happened is that, remember with the male, you started with the spermatogonium, and then that split mitotically. One of them stayed behind. The other one went into meiosis. Okay? And from that, you got 4 sperm cells being produced. In a female, it's different. The day she's born, instead of the primary spermatocytes, all the primary oocytes are already there. That means that they've already gone through their mitotic division, and in fact, they are stalled after meiosis 1. They're in suspended animation. They have not gone all the way. So they're kind of like waiting. And then month by month, some of those oocytes will start to come out of suspended animation, so to speak, and enter into meiosis 2 to finish off. So each primary spermatocyte could potentially give rise to 4 eggs, but they don't. Only one of the 4 actually survives. The other 3 don't. The other 3, in fact, give all of their material, all of their cytoplasmic material, all their organelles, all their mitochondria, all their raw materials, they give it to the egg. Whichever one is going to be the egg, it all goes there. And they are called polar bodies, and they die. They degenerate. That's why, for guys, one spermatocyte produces 4 sperm, but for females, one oocyte produces 1 egg, because the other 3 never make it. Okay? Anyway, so this one here is a primary oocyte. It has been living in suspended animation from the day that girl was born. Okay? And this is
Primary what?
okay. What I'll do is I'll put this up here /28. So this is primary oocyte. And if asked, the primary oocyte is arrested in prophase in prophase,
Mr. Hayden,
just hang on a sec, of meiosis 1. Okay?
what
Yes,
is-
dear.
What is oocyte? Oocyte? Ovus?
Oocyte. 2 O's. Yeah. Actually, I think the proper is something like that. 2 little dots above the second O. Okay? So what this is, so this is the primary oocyte. Now, you see these little dots here? These little dots are all cells as well. These are called granulosa cells. Okay? Now, remember in spermatogenesis we said the Sertoli cells are like nurse cells for the developing sperm? Well, the granulosa cells are the nurse cells for the developing egg. Okay? So these are nurse cells. And you notice that there's tons of them, right? And what you should get of this is as this thick process goes on, more and more granulosa cells, they divide and produce more and more. Okay? Pardon me? What do you want to do? Oh, that? Granulosa. Granulosa. Granulosa cells. Nurse cells. Granulosa cells are the nurse cells. Okay? Okay? B, at this point here, is called the primary follicle. Oh, thanks. This is called the primary follicle. And it is producing estrogen. At this point. And this is actually having an effect on the endometrium. It is because the estrogen is carried by the blood. And this is causing endometrium development. C is the developing follicle. Okay, so I need to take a little bit of a sidebar here. During this stage, to about here, so we're having this developing follicle. What is happening is at the anterior pituitary. Sorry, thank you. At the anterior pituitary. What's happening is that it is producing something called FSH. You say, well, Mr. Hayden, there's an FSH in the male? Yeah, it's here too. FSH stands for follicle stimulating hormone. This is the follicle. It is being stimulated by a hormone produced in the pituitary. Okay, so the name of the hormone tells you what it does. Okay? And so stimulating hormone. I'll write it up here just as a reminder. Follicle stimulating No. We go back. It's okay. Human brain.
It's in the brain.
Yeah. Okay.
Also, why are there so many hormones? Like, what do they do?
See what?
Hold that thought for about 3 days, because it's no one hormone does everything. It's based on relative levels of them, and that's where your brain is going to go boom. So all this time, right from here, this way here. Just hang on a sec. All the way this way here, all the way to about day 13. This is called the follicular phase. From day one, where the primary oocyte that was arrested in prophase, as soon as it starts developing, starts being surrounded by granulosa cells. Granulosa cells replicating and replicating, producing more and more hormones there. You will read about that shortly. The estrogen. So here's the idea. The granulosa cells are producing estrogen. And the more granulosa cells you have, the more estrogen is being produced. So what's happening here is estrogen levels continue to climb. Okay? That's what's happening because there's more granulosa cells, right? And so this occurs, this upward trend continues to go until about day 13, when it reaches this huge peak. As a matter of fact, it surges it there at that point. And what happens is that surge of estrogen produces this ovulation. So this is, so when the egg is released by the ovary, the fimbriae wave it into the fallopian tubes or the oviduct. So that's what's happening here. Now, one of two things can happen, and we're only going to do the scenario where there's no pregnancy occurs. So this is happening on a monthly basis for all females that have reached puberty. Okay? So from here on, once the egg is released, this thing here that was the follicle starts to degenerate. This is now not called the follicle, though. It now has a new name. It's called the corpus luteum, or corpus luteum. Okay? But let's finish off what's going on here. D, now, the big question is, what's happening here? What's happening in this space? Well, it turns out that just by the very life cycles of these granulosa cells, they also produce a liquid just as a byproduct. And the byproduct continues to build up and build up within the follicle. And so what you see is this space being developed. The developing follicle, though, now the egg, you'd probably call this the egg by now, it still has granulosa cells which are continuing to nurse it, giving it material, but it's also continuing to produce all of this fluid. But the pressure of this fluid builds up so much that this pressure is what actually is the trigger to release the egg out of the ovary. Crazy. Okay? So that's what's happening here. So just for the sake of the list here, D has, at this point here, just prior to ovulation, this is a special name. It's called a Graafian follicle. 2 A's, actually 3 A's. Graph.
Definition of developing follicle. You skipped it.
It's just a, so follicle is developing. Again, it's still producing estrogen, so this is pretty much ditto. And also, so all this is true here, but it is also producing fluid-filled cavity. So when it gets to its maximum size, it's called a Graafian follicle. And so this is characterized by increasing fluid and pressure. 2 A's, yeah, Graaffian. Sorry, that N looks pretty bad. Yeah, N is in nutcase. It's not a comment. I don't know. That's an N. Three bumps is an M. Come on, get in the game.
Why would you put one letter cursive?
Leave me alone. Always one in the crowd. No, actually, there's two in the crowd. Forget it. Okay. Fluid and pressure. It's still producing estrogen. Still producing estrogen. And the reason, again, for the estrogen, if you just, I don't know if I should write this again, but see, the producing estrogen is really for development of the endometrium, okay? And so as it goes on, we have, again, continued endometrium being developed, still estrogen, still more endometrium. More just continuing build up.
Wait, through A, B, C, and D,
It's just the follicle is continuing to develop. It's continuing to produce estrogen. That affects that's picked up by the blood, sent to the uterus. Uterus picks up that chemical signal, continues to build up the endometrium. Okay? As long as we've got the follicle in place, estrogen is being produced, the endometrium continues to build. Okay? Once the egg is released, that all changes. Okay? And there is an estrogen surge. I'm going to put ... This produces, I'm going to put ... here, ovulation. And so basically that's just release of egg into the oviduct. Okay? So at this point here, the egg is still not fully developed. It's actually arrested in metaphase of meiosis II. Okay?
Is it called ovulation?
Yeah, ovulation. Stand a sec. Gentlemen, not yet. Goodbye.
Get some paper towel.
No, go away. I love you. I love you. Go away.
Never heard you say.
Happens sometimes. Okay? F down here, I've already mentioned this, is called the corpus luteum. The corpus luteum produces, or it increases. It's actually, to be honest with you, progesterone has been being produced all along, but it's been produced at a baseline level. Once the corpus luteum is formed from the old follicle, it starts to increase progesterone. And the progesterone, this also has an effect on the endometrium. It also increases the endometrium. So, progesterone. The name progesterone tells you what it does. This is, you can think of pro as meaning promotes. The GEST refers to something we call gestation. Gestation is the word that we use for development of the embryo. Okay? The ONE at the end tells you that this is a protein. Okay? So progesterone is a protein that affects the development or promotes the development of the embryo. Okay? Now, just one last thing, and I'll let you go. At this point here, if there is no pregnancy, then the corpus luteum degenerates to nothing. If the corpus luteum degenerates to nothing, that means that there is no production of estrogen and there is no production of progesterone, which means there is no endometrium. So if this degenerates, that's the trigger for menses. Let me go away.